coffee in a cup at time t minutes is modeled by a decreasing differentiable function c, where c t is measured in degrees Celsius, where 0 is less than or greater than t, which is less than or greater than 12. Selected values c of t are given in the table shown.
Part B?
Use the left Riemann sum with the three subintervals indicated by the data in the table to approximate the value of integral 12 to 0 c to t dt. What is that?
Interpret.
The meaning of 1 over 12 integral 0 to 12 c of t dt in the context of the problem.
Okay, let's go ahead and underline left Riemann sum. And then we have 3 subintervals. And then after that, we're going to interpret what that basically means with the average value. Okay, let's go ahead and make our 3 loops. So I have 1, 2, and 3. The Riemann sums you cannot miss. It's almost like a freebie. Because I'm doing the left Riemann sum, am I using 100 or 85? 100, very good. So I'm going to leave that up to you and hide the remaining. So we have our left Riemann sum is going to be the integral. It's the area under the curve, basically. 0 to 12, c of t dt. So it's 100, and what's the change of the x values, or the t value? It went 0 to 3, so the difference is 3. What's my next left value? 85, and what's our changing our t's? 4. And then what's our next left? And our changing of t? 5. Let's type that in. It'll be a clean number of 900 something. 985. Okay, let's see the point breakdown. Knowing how to write out the left Riemann sum, that's going to give you 1 point. And also, the actual value after you type that in correctly is 1 point. Isn't that a freebie? For every AP test or FRQ, since it's out of like 9 points, if you can get 4 to 5 points, it's pretty good. And you already got 2 right there. Okay? And then it says to describe what it basically means. So I'm going to go back to my original question. And when I'm interpreting the meaning, you have to include everything about it. So I want to include what this is and then the meaning behind it. So I'm going to start with that phrase right there. So here I go. So write with me. So the average value of 1 over 12 of the integral from 0 to 12 of the function given is the average temperature over the what? Average temperature. We're measuring the temperature of the what? Coffee. Of the coffee. From what time to what time? What's my bottom and top? Good. Coffee in a cup. I guess writing more is good. Over the interval from t equals 0 to t equals 12. So having all that, it's going to give you another point. So always write more. If you're like, can I just write 0 to 12? I think it'll be fine as long as you include the word time. But did I use the word time anywhere? Because I didn't include the time, I should write t is equal to 0 to 12. Is everyone good with that? All right? Now let's go on to part C. Okay, I'm going to move this over. If you're ready, give me a thumbs up. That's the average value. When you divide it by the time interval, it's the average value. Okay, now let's go on to part C. Okay, on part C, Costello Street.
For 12 is less than or equal to t is less than or equal to 20. The rate of change of the temperature of the coffee is modeled by c prime of t equals negative 24.555 e to the power of 0.01 t over t, where c prime of t is measured in degrees Celsius per minute. Find the temperature of the coffee at time equals
Okay.
t equals 20.
Very good. I want you to underline Celsius per minute. Isn't Celsius per minute the slope per something? So that would be C prime of T. But the temperature actually is C. Is everyone good with that? Is a dropping of the temperature or increasing of the temperature is C prime? And then the actual temperature is C. Good? So if I were to look at the interval from 12 to 20, I want you to look at the card number 6B. It's our fundamental theorem of calculus. And I'm going to mimic what's happening right here. So if I were to mimic what's happening right there, we are looking at, and I want to go ahead and use this one right here because we have C prime. So if you want to go ahead and write on here, we have the integral from 12 to what? 20. And we have C prime of t dt is equal to, mimicking this formula right here, we have, if that was f prime, that is f, so I need C of the b value. What's our b value? 20. What's our a value? A value is 12, because it's top minus the bottom. And then let's do some math behind it. Our goal is to look for what? Find the value of C of 20. So let's go ahead and isolate everything. If I move the C, well, I'm not going to move the C by using algebra, but I'm just going to leave it on one side. But instead, I'm going to add this to it. So when I add that, I get C of 12. And then we have plus the integral from 12 to 20. And then we have C prime of t dt. Now something's already given to us. Do I know what's happening at 12? Look at your table. When t equals 12, was that 12 or 20? 12, how many was our C of t? 55. So I'm going to write C of 20 is equal to this value right here is 55 by the given. Plus our integral of 12 to 20. In our prime, we're going to actually type that in. C prime of t dt. Because that function was already given to us, you don't have to write out the whole equation and waste your time. Y'all good on that? Anything that is previously stated, you may use that with the variable. So let's all type this in together. We're starting with 55. How do I get to the integral on the calc? Math what? Math 9. And you pretty much mimic exactly what you have on your paper. And then we have our function. Oh, I should have saved my function on the other y2, but I did it. That's okay. Okay, let's type in our function given. So it says our C prime of t was negative 24.55. My e to the power of 0.01 x. On the bottom we have my x and dx. Okay, I'm gonna double check. Okay, do y'all have what I have basically? Yeah? Okay, I get 40 something. Is that what you have? Okay, so we have, that's just gonna give me 40.329. And that's degrees in Celsius. And let's look at the breakdown of the points. Having the initial value is gonna give you 1 point. Having the whole integral with upper and lower bound is going to give you another point. And your final answer with units, 1 point. So how many can we get from this? 3. Okay, and then our last one. If you're ready, give me a thumbs up. Can y'all close your devices? Okay, my last one. Okay, Kendall, go ahead and read part D, please.
The model defined in part C can be shown that C double prime of t equals a bunch of those numbers for 12 is less than t is less than 20. Determine whether the temperature of coffee is changing at a decreasing rate or at a increasing rate. Give a reason for your answer.
Okay, so we're comparing double prime this time. So let's kind of think about our PVA. Y'all ready? So if double prime is positive, is it increasing rate or decreasing rate? Increasing. If double prime is negative, it is what kind of rate? Decreasing rate. So I already have double prime, so all I need to do is graph this on my calculator. So on this one right here, let's go ahead and graph this. And when we graph this, I might change the window a little bit. So let's do alpha y equals. I hope everyone's typing, because that's the minimum amount of work you can do on the AP test. Type what's on the paper. And then parentheses. The bottom is t squared, which is x squared. And let me double check. Boom. And I'm gonna actually draw the model, and it's not gonna be perfect, because it really depends on where your window is set at. So on here, part D, I want you to go ahead and give me a little sketch of the graph. And I'm looking at up to 20. It might be a little skewed, maybe not, we shall see. So on my window, I think I wanna go a little bit past 20. Maybe like 50 might be good enough. And I'm just gonna go to graph. And we're looking at the behavior of the graph. Okay, the piece that I care about is from 0 to 20 or 12 to 20. Do y'all see it's kind of like declining all the way and getting closer to the asymptote? Okay, so here's my simple sketch. It is doing something like this is all that matters. Because if you look at our PVA card, if my F double prime, is my F double prime, this graph right here, is it all above the x-axis or below the x-axis? It is above, it's positive. When F double prime is positive, what's happening to our single prime? It is increasing. So then let's go ahead and phrase that. When I phrase this, you want to be able to use the phrasing of their last sentence. So I'm going to say something about temperature of the coffee. This one is going to be increasing. So increasing rate, I'm going to use that word right there. And I think I'm also going to use the word temperature of the coffee. And I'm also going to use C double prime. Do you have to write out the whole equation again? As long as it's initially stated, you may use C prime, C double prime, and so on, okay? So here I go. And if you're a great writer and you have a fancier way to write it, go for it. I'm not the best writer, so here I go. I'm gonna say since C double prime of T is greater than 0, you could say positive, they mean the same thing. You have to always mention the interval. The interval that they gave us is from 12 to what? 12 to 20. The temperature of the coffee, not of it, is changing at what kind of rate? Increasing rate. And that is all they want. So I want to double check. Did I mention the function? I did. The behavior of it, the interval, what is the item, and what is happening. Good? So then, the way they're going to actually give you the point on this one, because you're simply analyzing the picture, all that reasoning is just simply 1 point. And again, avoid using the pronouns like it, okay?